A student launches an air rocket from the ground straight upwards at a speed of 23.5 meters per second. To what height does the rocket rise before going back down? What total time does the rocket spend in the air? Okay, we're going to have to use tricks here. Okay, so here's this thing, and it's going to go up, and it's going to go down, right? And whatever time it takes to go up, it'll take the same amount of time to go down. So we'll figure out the time to go from the bottom to the top. Okay, so let's do this from the bottom to the top. Okay, to the top. That's an O. Okay, so we're going to go from down here to the top, and that'll give us our height. That's what we have to do. Okay, so straight upward at a speed of 23.5 meters per second. So our initial velocity is 23.5 meters per second. Our final velocity at the top, is 0, because if it's not 0, it's not at the top, is it? There we go, right? So that's the top. Okay. Our acceleration all the way up is negative 9.8. Of course, this means that it's what? Slowing down, right? It's got a positive velocity, negative acceleration. So therefore, all the way up, it slows down, right? Okay. Which is, of course, why it stops. All right. Let's see. To what height does it rise? So I guess I use no t to find x. Let's do that. Let's do it. So Vf squared is Vi squared plus 2ax. Plug the numbers in. Final velocity is 0. So 0 squared is 23.5 squared plus 2 times negative 9.8 times x. All right. So 23.5 squared. All right, so we have 0 is 552.25 plus 2 times negative 9.8 times x. And then, of course, what I'm going to do is put this on this side and make it negative, right? So negative 552.25 equals 2 times negative 9.8 times x, right? And now I just take that number, right? Negative 552.25 divide by 2, divide by negative 9.8, and that's going to be x, and x is 28.176. Notice it ends up being positive because of the two negatives. That's my x. So the displacement from here to here is positive 28.176, 28.2 meters roughly, right? Ta-da, we got our first answer, right? And then what time does it take to do that? We can do that. I'm going to use no x to do that. So Vf is equal to, I don't know what that was, Vi plus At. So let's see, final velocity is 0, right? So 0 equals 23.5 plus negative 9.8 times t. All right, the next step is we're going to subtract 23.5. So minus 23.5 equals negative 9.8 times t, right? And then ultimately, I'm going to go negative 23.5 divided by negative 9.8. And I get that our time is, put a comma there, right? Time is equal to 2.397. 959. Now understand that that's our time to go up, right? 2.397959, right? And it's also going to take the same amount of time to go down. So 2.397959 is equal to, well, this plus this, I'm just going to multiply by 2. So times 2. And I get that the total time, because notice it says time up plus time down. What total time, whoops, does the rocket spend in the air? Total time is 2 times 2.939939, whoops, 2.39759, right? And that is 4.7959 seconds, right? Which is about 4.80 seconds total time in the air. Okay, so once you figure out the time to go up, the total time in the air is, if it's symmetrical like this, that is, it lands at the same time, at the same height, right? It's just, you just multiply that time up by 2. Okay, yeah.